Hello. What you've already learned about so far is we've talked about the Pearson's correlation coefficient. And so now we're going to talk about something else that's called Spearman's rank correlation coefficient. And rank here is the key word. Let's talk a little bit about this piece of data right here. What I would like for you to do is enter this data into your calculator. So we're going to do all of this. I want you to first be able to see what this is as a scatter plot. So if you have a TI Nspire, you can go ahead and follow along. If you do not, I would like for you to, on your own, research how to do this with a TI-84. I'm sure it's similar, but I'm not entirely sure. So what I want to do is I want to label this whole column as a Y value. So I'm going to hit the var button that's right here. And it's going to say store variable, and I want to store that. And I will want to call it just whatever you want to call it. I like to call it Y because I know that that's going to be my Y values. Press enter. I'm going to do the exact same thing with this A column. I would like to store it as my X values. So that's the first thing that you have to do is you have to enter in all of your data, and then you have to say, hey, this column is the X column, this column is the Y column. Then you need to add a new page to this document. So if you go to Doc right here, and then if you go to Insert, and then you go, we want to insert a graph. So I'm going to scroll down, or you can press 4, right? But I'm going to insert a graph. And now it's inserted a graph page next to my spreadsheet page. If you want to toggle back and forth between them, all you have to do is press Control and then over this guy or over this guy, because you see this blue guy is saying, hey, you're changing pages. So if I wanted to go back to my spreadsheet, I would hit Control and then to the left. There we go. And it's brought me back to my spreadsheets. I'll hit Control and then go to the right, and I'm back to this guy. How I insert a scatter plot is I need to go to Menu, and then I want to do a graph entry, and I want to enter in a scatter plot. So what I want to put in for my X values is my X variable that I just listed on my other piece of my document. And then what I want to go into my Y values are my Y part of the table, and then I'm going to press enter. Notice we have one point right here. That's your 0, 0 point. If I change how I zoom, I'm going to do zoom fit. So I'm going to press A. It creates a scatter plot for us right there. So that's how you do it on a TI Nspire. You'll see me do it a couple more times. Maybe you want to pause the video or go back in the video and write out what the steps are and how to do it. It's going to be important to know how to do this for not only these notes, but also your homework and tests. Our scatter plot looks something like this. So if I were to quickly sketch the idea of the scatter plot, there's one here. And then the idea is that it levels out with something like this, that this is our months, and this is our change in percent value. And so here's the general idea. We go all the way up to 24. We go all the way down to negative 87. I would also like for you to find your Pearson's correlation coefficient here, so your R value. I'm going to toggle back to this guy. I'm going to do my statistics calculations. Remember that it's a 2-variable statistics. I need to make sure I include A for my X list, B for my Y list, put my entries into C, and R is negative 0.874. Negative 0.874. So that would tell us that it's a fairly strong correlation, a fairly strong negative correlation. However, we do not want to use Pearson's correlation coefficient in this case because of why. Because this guy is not a linear relation, a linear correlation, we cannot use Pearson's correlation coefficient. And so if we still want to talk about how great of a correlation it is, right, it's very clearly an exponential correlation. And so it's a great, it's very correlated, right? So it's a strong correlation, just doesn't happen to be a linear strong correlation. And so what we want to do to prove that it is a strong correlation, but not a linear correlation, is that we then have to take this relationship and we have to rank it. So it grossly simplifies down the data that you got, right? So this is complicated data. It's very descriptive data, right? So we know in exactly what month, what the change in the percent was. And what we're doing is we are going over here using the same data and we're ranking these numbers. Number 1 equals the biggest number. So that's something to keep in mind. So notice that they took the biggest number. If we're just looking at your X values being compared, because you just do one at a time, your biggest number here is 24, and that gets the rank of number 1. That gets the rank of number 2, of 3, of 4, of 5, 6, 7, 8, 9, 10. It won't always be nice and organized like this, but for the first time that you see it, that is what's going on. Now 0 is the largest number in the change in percent value, because then all of these guys go to negative. So 0 gets the 1, and then negative 87, which is your smallest number, gets 13. Now, I would like you to enter the rank correlation into your calculator. So then if we take this data and we enter it all in, make sure to go back and delete your previous data entries and now enter in this new data. I've entered it all in. I've now restored this with an X and restored this with a Y. And I'm going to again insert a graph page and then insert a scatter plot. Make sure to hit vars and then enter in your X and Y that's been stored in your vars button. So I hit there vars and then X and then vars and then Y. I'm going to hit menu, zoom, and then fit to be able to see what's going on. And here is our fit zoom of our ranked data. And so notice how they've taken the idea of what is this relationship truly, which is an exponential equation, and then they turned it into, the rank turned it into a linear relationship. And so the Spearman's ranking idea takes it and turns it into, for the most part, a fairly linear. So this is loss rank, and this is month rank, turning it into a fairly linear relationship. Now, if I were to go back to this previous page and do my calculations again on finding what I normally would do to find Pearson's, so to find my R, I go down and look at my R, and it is different. Negative 0.9945. And this rank is now the true Spearman's rank correlation coefficient. And so now we can use this number to represent how strong of a relation it is, as well as the direction that it is going in. So we say it's a fairly negative, strong correlation. We put an S down here at the bottom to make sure that we realize that this is not a Pearson's correlation, so this is for a nonlinear relationship. And that's pretty much the main difference. All right, so that's the main idea, that we have two different R's. This one we can't use because this relationship is not linear, and so then we rank the data and then use this correlation coefficient, and then that can be used, this R sub S, S stands for Spearman's, which can be used on a nonlinear relationship. And then we see the difference is that what we've done is we've taken our data that was exponential and turned our data into something that was linear. That's the main idea. So the hardest part sometimes is just turning your data into a rank. So if I wanted to talk about X rank and Y rank, remember that your data here, when we are ranking, that number 1 goes to the largest number, So for our x values, 30 is the largest number, and then 25, 20, 15, and so on. Whereas with this guy, 23 is the largest number, and then 18, and then 10. And then here can be something that's a little bit tricky. When you have the same number being repeated, it's taking up the 5th, 6th, and 7th spots in our ranking coefficient, but they're not in different levels, so they need to be represented as at the same level. But we can't call it like 5, 5, 5 because we're not taking into consideration that there are more ranks than that. So what you have to do in order to find out this data is you need to find the average of whatever is repeated. So for instance, this would be the 5th, 6th, and 7th slot, but since they're all the same number, we would take 5, 6, and 7 and find the average of that number. Since I added 3 numbers, I would divide by 3, and all I get is 6. So then for the Spearman's rank coefficient, I would put 6 here for all 3 of those positions. So if you see a number that is repeated, you need to take into consideration which slots they're taking up, even if they're tied. This could have been 5, 6, 7 or 5, 6, 7, right? But either way, they're taking up the 5, 6, 7 spots. So you need to find the average of those spots, which in this case happens to be 6, and then that will give you what number goes with them for their Spearman's rank. So this is important. IB definitely will give you a question regarding how to rank this when you have numbers that repeat. Okay, so let's practice again. I would like for you to go ahead and do this on your own. I'll have you just type in the order that they go in. So see, like for up here, I would have done x equals, and then I would have done 7, 6, 5, 4, 3, 2, 1. And then y equals 1, 2, 3, 4, 6, 6, 6. So all I want you to do is show me that in this progression, right, we matched up in these columns, what your rank would be. So I want you to try it on your own. There are not numbers that repeat on this, so you don't have to practice that. Just practice ranking it. Okay, so for this top row, I know that 14 is going to be the first one, and then 12, and then 10, 9, 8, 6, and then 3. And that is how it should look, just trying to make sure to match up what is the largest number to the smallest number. And that's all you have to do for ranking. All right, so then let's talk about doing IB